So 1.2 arithmetic series is still part of our R9 outcome, but instead of looking at just the sequence, so just the numbers, just those values that come together to make a pattern, an arithmetic series actually looks at the sum of terms in an arithmetic sequence. So remembering that sum means that we are adding. So going back to the sequence that we started with in our previous lesson, we're looking at 2, 4, 6, 8, 10, etc. And remember that dot, dot, dot was so important because it kept going to infinity. When we write the arithmetic series, we're going to do the same thing. So we're going to do 2 plus 4 plus 6 plus 8 plus everything after it. So we still include that dot, dot, dot. When we talk about the value of a series, we use this S1 as our notation, or SN in general. So for the sum of just one term, it's just term 1. So it's just 2. The sum of the first 2 terms well, that means that I'm talking about term 1 and term 2. So it's going to be 2 plus 4, which would be 6. The sum of the 3 first terms would be term 1 plus term 2 plus term 3. So I've got 2 plus 4 plus 6, which is 12. In general, we do have an equation that lets us solve for this. And actually lets us do it 2 ways. Option 1 actually doesn't even require the common difference. So if you don't know your common difference, you just know your first term and the last term, you can still solve for your sum as long as you know how many terms are in between it. Okay, so that's this first one. Notice no D. Our second option is if we only know our first term and our common difference, and we know what we're trying to get to, but we don't actually know term n, then we're going to use this one. So if we don't know our nth term. Okay, so either one of those will work. Depending on the scenario, one might be a better option than the other. So let's have a look. Determine the sum of the first 6 numbers of this arithmetic series. 25 plus 14 plus 3 plus -8 or -8 minus 19 minus 30, and we're going to keep getting more negative. That's why that's subtracting there. So step 1, just identify some variables that are going to be helpful. So term 1 is 25. We are going up to term 6. So that's going to be -30. And so n is going to be 6. We could also determine D by looking here. Well, that is -11, -11 again, -11 again, and so forth. The pattern continues. So D is, we're decreasing by 11 each time. Step 2, figure it out. So you could technically pull out your calculator and do this one using your calculator, and that would be an okay thing to do, but I'm not going to do that. I want to practice using these equations. So I'm going to use both just so that you see kind of how they work a little bit different. So using the first equation, first formula, we've got S6 equals, and so it's n, which is 6, times term 1, 25, plus or minus 30, because it's -30 is term n, term 6, divided by 2. Given that, we've got 6 times -5 divided by 2, which is -15. Or I could have used the other equation. Again, I'm going to scroll up just so I can see it. N is still 6 times 2, term 1 is 25, plus D, which is -11, multiplied by 6 minus 1, all divided by 2. So here again, we kind of follow our rules of or order of operations. So we've got 6 brackets 50 plus -11 times 5, so that's actually going to be -55, all divided by 2. Well, that's going to be -5, so we actually do end up with the same answer. So again, either equation, either formula works. And that works out very nicely when we're able to identify all 4 of these characteristics.